Alright, let's take a look at the different steps in graphing a rational function. We looked a little bit about asymptotes. We've done x and y intercepts before. So mainly 7 steps here, although a lot of them go fairly quickly, but we need to take a look at all of them. And we did a couple of these in that last little section in the last video. So first thing we want to look at, simplifying. In other words, when we've got our rational function, which remember is going to take on the form something like f of x equals our numerator, which is still a polynomial, so our numerator in terms of x and our denominator in terms of x. So polynomial on top, polynomial on bottom. We want to simplify. So in other words, if the top can factor, if the bottom can factor, do that. It's going to help some of our other steps, but then also if you can reduce by canceling entire factors on top and bottom, do that. Second thing is we want to find our intercepts. So for our y-intercept, every x that's in numerator or denominator we're going to let be 0, simplify whatever we get, that's our y-intercept. Could be one, could be multiple ones. X-intercept, all we're going to worry about is the numerator. So we're going to let every 0 up on top, or every x up on top, find the zeros of that, and that's going to be our solution. So that's our x-intercepts. Vertical and horizontal asymptotes we just talked about in the last video. For vertical asymptotes, we just have to take the bottom and find the zeros, which again basically turns out to be our domain. And for our horizontal, we had our 3 rules, whether the exponent on top was smaller than bottom, which meant our x-axis itself, or y equals 0, was the horizontal asymptote. If the 2 exponents, top and bottom, were equal to each other, then we just took the 2 lead coefficients and said y equals that, and that would be our horizontal asymptote. And again, if the bottom and top, or if the top was bigger than the bottom for the exponents, there would be no horizontal asymptotes. But if the top was exactly 1 bigger, like x to the third compared to x to the second, then we would be looking at oblique. And we will look at an example of that a little bit later here. Then what's going to happen is our graph is going to get split into regions, and the regions are going to get split up by our vertical asymptotes and by our x-intercepts. And again, this will become more evident when we do an example in a second here. Once we've got all of the pieces together here, we can finish it out by smoothing the curves and making our graph. So let's take a look at an example, and we'll start with one that's fairly basic with not a lot to it. So we'll start out with this as our equation, or our rational function that we're going to deal with. So we're going to have f of x equals 3 over x minus 2. Alright, so with our f of x set up here, let's go through our steps. So step number 1 again was simplify. So again, with our simplification, all it is factoring and reducing. So in this particular problem, there's none to be done. All right, our second step, our y-intercepts. So we're going to let every x be 0. So for this one, we would get 3 over 0 minus 2, which is just negative 3/2. And now so we can kind of keep up as we go here. Let's set this one up. So we get our graph set up out to the side here. So first things first, like I said, we got our y-intercept at negative 3/2. So we'd go down negative 1.5, and there's going to be my y-intercept. So that's the first one. Third step was our x-intercepts. So this was our y-intercept. And then our x-intercept, we said we were going to find the zeros of the numerator. Well, in this case, the numerator is 3. If I set it equal to 0, it's not going to be true. So this just means there's going to be no x-intercepts, which is good. Alright, so go to our fourth step. The fourth thing that we're looking for was our vertical asymptotes. Now again, our vertical asymptotes, we take the bottom and we set that equal to 0. So we're going to do x minus 2 equals 0, add 2 to both sides, and I just get x equals 2. So x equals 2, I'm going to go out here, and this becomes my vertical asymptote. My fifth step, horizontal asymptote. So on this one, I'm going to look at top. So my top has an exponent of 0 for the lead coefficient. My bottom has an exponent of 1. So in this case, the top is smaller than the bottom, and when we ran into that, that implied that y equals 0 was our horizontal asymptote. So actually, x-axis itself now becomes an asymptote. Alright, our sixth step, this is one we didn't really talk about yet, was regions and test points. So on this one, we have no x-intercepts, but we do have a vertical asymptote. So everything to the left, we're just going to call region 1. Everything to the right, we're just going to call region 2. So I need to pick some values to the left and to the right. Well, let's start out with to the right. So let's just go with 3. So if I let x equal 3, I would plug that into my problem up here, and I'm going to get 3 minus 2 on the bottom is 1, and 3 over 1 is 3. So when I plug 3 in, I get a function value of 3 out. So I would have 3 to the right, 1, 2, 3 up, and I at that point. Now that gives me a couple things. One, it's going to tell me I'm going to stay above or to the right side of this, which I knew because I chose a value to the right. But also, since I don't have any x-intercepts, I know I'm never going to cross my x-axis. So that's where my asymptotes basically turn themselves into magnets. So I could pick a few more points to get more exact, but since we're only worrying about sketching this right now, we'll just take that point and draw it closer and closer to the vertical asymptote, and then we'll extend it closer and closer and closer to the horizontal asymptote, but not touching or crossing either one. Now normally we would also take region 1 here and pick a value, but nice thing is we had a y-intercept here, so we already have a point to the left side of our horizontal or vertical asymptote. So same thing, we're going to take this one, run it close like a magnet, draws it towards that line, and we're going to do the same thing up here. Now again, we can get more accurate with the drawing by doing more points and plugging in for x, but since they only want to sketch, that's going to be all the further we're going to take this one. So, pretty simple startup, but it gives you an idea of how we can work with all the steps and dealing with the asymptotes as well and how they affect the graph that we're drawing.